In this lesson, we are going to introduce operations for radicals. So numbers such that square root 10, square root 25, square root 72 are called radicals. Radicals is a sign, radical sign, the root of a quantity. And by default, there's no numbers here, means it's 2. It's a square root. And you could see other numbers at front of this radical signs. If it's 4, then it's fourth root. If there's no number, it's square root. A radical with coefficient 1, such as square root 8, is known as an entire radical, and the quantity under the root sign is called the radicand. So 8 is radicand, and the whole thing is entire radicals. And if we could simplify 12 square root 12, we could write it as 4 times 3. Square root 4 give you 2. We call it mixed radical. The reason why we want to convert from entire radical to mixed radical, because when we're doing adding, subtracting, we could find the like terms. The like terms means same radical sign and the same radicand. For example, 3, and this one, the number is not, the index number is just a 4 at front of times square root 3. These two terms, we call them like terms. We could adding, subtracting those like terms together. So same radical sign, same radicand, they are like terms. We could do it like terms. Square root 3 plus 4 square root 3 give you 5 square root 3. So we treat the square root 3 as a unit. $1 plus $4 give you $5. So now we know that if we could have the mixed radical, we could add, subtract the like terms. So we are going to practice with convert these radicals to mixed radicals in simple list form. What it means is take the perfect square out. So square root 48, the perfect square number in 8 is 16, then times 3. The square root 16, we could take it out. So square root 16 is 4, then times square root 3. So this is a mixed radical for this entire radical. And the square root 54, we have perfect square number 9, then times 6. Square root 9 give you 3, then times square root 6. So you are looking for the perfect square number. 5 square root 28. So 28, we could write it as 4 times 7. 4 is a perfect square number. So 5 times square root 4 give you 2, then square root 7. We have 5 times 2 is 10, 10 square root 7. So this one, 3 square root 5, we go back to entire radicals, means we bring the 3 into the radical sign. So square root 3 squared, then times 5. That equals square root 45. So this mixed radical, we couldn't put a negative into that radical sign. So it's 5 squared times 7. Then we have negative square root 25 times 7 give you 175. This one bring 8 into the square root is 2 squared, then times 3. Then we have square root 12. So you need to know from entire radical to mixed radical, from mixed radical to entire radical. So we are going to see the rule. Square root a plus square root a, you have the same radical sign and the same radicand. We call them like terms. We could add the number at front. 1 plus 1 give you 2. And if it's multiplication, you have the same radical sign, then you can times the radicands together. If division, same radical sign, we could divide the radicands. So these are the 3 rules: adding and could apply to subtracting. As long as you have same radical sign, same radicand, you could add and subtract the numbers at front. Multiplication, same radicand, you could times the same radical sign, you could times the radicand together. Division, same radical sign, you can divide the radicands. So you have 3 rules. We are going to see this is multiplication, same radical sign. Then we just times the radicand together. We have square root 77. Then this one, numbers at front times. So 5 times 4 times 1. Then times the radicand, square root radicand 2 times 3 times 30. Then equals 20 square root. 2 times 3 times 30, we have, here we have 180. Then we need to see any perfect square from this radicand. So 20 times square root, we have 36 times 5. Then square root 36 give you 6. So 20 times 6, then times square root 5. We have 120 square root 5. Then you may wonder how you can find the perfect square number. We could create the factor tree. So 180, you have this even number could be divided by 2. Then 180 divided by 2 give you 90. Then continue, 90 is even number could be divided by 2. Then 90 divided by 2 give you 45. 45 could be divided by, now 2, we can try the 3. So 45 divided by 3 give you 15. Then this one we could divide by 5. 15 divided by 5 is 3. Now we are going to see if you have any 2 numbers repeat. So 2 times 2 is 2 squared. That is a perfect square number. Then 3 is 3 squared. Then times 5. So 180 have 1, 2, 3, 4, 5. 5 prime factors. Then you times these 5 prime factors together equals 180. From there we have 2 perfect square number. So 2 squared times 3 squared is 6 squared times 5. So that's the reason we have 36 times 5. Then we can square root 36 out to get 6. So this is how you use a factor tree to find the factors of 180. So 2 times 2 times 3 times 5 times 3 give you 180. The end of the branches of the tree give you the factors for 180. So times them together, you have 180. Then this one, division, we are going to divide the numbers at front of the radical sign first. So 2 and 16, the common factor is 2. So 2 divided by 2 give you 1. 16 divided by 2 give you 8. So you have 1 over 8. Then these two radical signs same division, you could just divide it by the radicand. So you will have 30 divided by 5. Then equals 1/8 times square root 6. 6, you have only 2 and 3. The factors no perfect square number, so just leave it there. And this one, numbers at front of the radical sign, we do the division. 15 divided by 3 is 5. Then square root, radicands, divide. You will have 5 square root 20. And the 20, we are going to find the factors. So 20 divided by 2 give you 10. 10 is even number, could be divided by 2 again. 10 divided by 2 is 5. Then you will see you have 2 repeat. It means you have 2 squared. So equals 5. Square root 2 squared times 5. Then we take the 2 squared outside of the square root. They cancel out. It's 5 times 2, then square root 5. It is 10 square root 5. So these are the operations for multiplying, dividing radicals. And also the final answer, you need to have the simple list form. So inside the radicand, no perfect square number. So we are going to practice more. And for this question is adding, subtracting. So 2 square root 3 plus 4 square root 3. Square root 3, they are the like radicals. We just add the number at front, count how many square root 3 there. So 2 plus 4 give you 6. Then this one, we are going to see the like radicals with the same radicand. So we have the square root 3, then the number at front, 3 minus 4 give you -1. You don't have to write the 1 there, so negative square root 3. And 8 square root 2 is like radicals with 11 square root 2. So square root 2 is there. 8 plus 11, you have 19 square root 2. So these two, you will see they are not same radicands, but we could try to simplify each of them to no perfect square number in it. So square root 8, we have the factor 3, so 8 divided by 2 give you 4. 4 divided by 2 give you 2 times 2, so you have 2 squared, so square root 2 squared times 2. Then minus square root 18 could be divided by 2, then 9. 9 could be divided by 3, so you have 3 squared times 2. Then we take the perfect square out. Square root 2 squared give you 2. Square root 3 squared, square root cancel out is 3. Then they are the like radicals, just a number at front, subtract. 2 minus 3 give you -1. You don't have to write the 1 there, so this is your simple list form for this expression. And this question, we are going to see, take the perfect squared out. So 28, we have 4, is 2 squared times 7. Then minus 2 over 3, 63, we have 7 times 9, 3 squared times 7. Then plus 2 over 5. 50, we have 5 squared, 25 times 2. Then we take the perfect squared out of the square root. Square root 2 squared give you 2. So 1 over 2 times 2, then square root 7. Minus 2 over 3 times 3, then square root 7. Plus 2 over 5 times 5, then square root 2. So for fraction multiplication, numerator times numerator, denominator times denominator. 1 times 2 is 2, 2 times 1 is 1, is 2, then 2 divided by 2 is 1. So square root 7. This one, numerator times numerator, denominator times denominator, 3, 3. 2 times 3 divided by 3 times 1. 3, 3 cancel out. You have minus 2. Then square root 7. Then plus 2 over 5 times 5 over 1. 2 times 5, 5 times 1 is 10 divided by 5, have 2. Then square root 2. The same radicals. Square root 7, they are the like radicals. We combine, collect these two like terms. So 1 minus 2 give you negative 1. Negative square root 7 plus 2 square root 2. So no perfect square numbers in the under the square root. So these are the simple list form of the radicals, and they don't have the same radicals. They are not like terms. You just leave it there. Then after that, we are going to do multiplication of the binomials with radicals. So first term in the first bracket times each term in the second bracket. So it's square root 3 times square root 3. Then plus 1 times square root 3 is 1 square root 3. Then the second term in the bracket times each term in the second bracket. Negative 2 times square root 3. Negative 2 times 1 is negative 2. Then square root 3 times square root 3 is square root 3 squared. Squared and the square root cancel out, you have 3. This middle, you have square root 3, they are like terms. Collect the like terms, 1 minus 2 is 1, so negative square root 3. Then plus 2. 3 and 2 like terms, 3 minus 2 give you 1. Then square root 3, that is done. The final answer, no brackets, no like terms. Then it is simplified, and under radical, square root, the radical sign, no perfect square. And continue, 3 times 4 and 3 times square root 6. 3 times 4 is 12. 3 times square root 6 is 3 square root 6. Then the second term in the first bracket times each term in the second bracket. 2 times 4 is 8. Then minus 2 times square root 6, square root 6. We have 12. 3 square root 6, 8 square root 6, they are like terms. 3 minus 8 is minus 5. Then square root 6 times square root 6 is square root 6 squared. Squared and square root cancel each other, so minus 2 times 6. Minus 2 times 6 is minus 12. 12 minus 12 is 0. So the final answer only negative 5, square root 6. Then this no perfect square number and the square root, so this is simplified. And the last one is multiplying, dividing the radicals. So the number at front times negative 3 times 4 is negative 12. Then under the radical sign, we times these two radicals together. Then we have negative 12 square root. 6 means 6 squared. The x 1 plus 3 is multiplication, the degree 8. 1 plus 3 is 4. For the y, we want to separate it with 1 is even degree, another one is odd degree. So if this is 3, we need to take out the even degrees, and the y need to be less than the 2 with roots. Then we have negative 12, square root 6 squared give you 6. You can take it out. And square root x to the exponent 4 is divided by 1 by 2. And y, take it out, 4 divided by 2. Then times y. So negative 72 x squared y squared is just square root of each of them. And for the y is not able to square root it, we leave the y there. So if it's squared, it's just same as either the degree divided by 2. And this one is division of the radicals, 7, 14. You can cancel 7 out. 7 divided by 7 is 1. 14 divided by 7 is 2. Then square root 250, the radicals divide x cubed y to the exponent 6 divided by 2xy. Then we have 1 over 2 square root. Do the division is 125. The x division, the degree subtract. 3 minus 1 is 2. Y to the exponent 6 minus 1 is 5. Then for the y to the exponent 5, we want to write it as separate. One is even degrees, another one is odd. The odd degree needs to be less than this nth root. This is 2, so we want this one to be less than 2. The odd number is 1. So 4 plus 1. Before is y5, we write it as separate y4 times y. So the reason why we want to write it here, because we could square root these two with even degrees. And 125, we have 25 times 5. So this one we could write it as 5 squared times 5. Then all the perfect squared we could take out from this square root. So 5 squared square root is 5. And x squared square root is x. Y to exponent 4 square root is y squared. Then square root 5y. That is done. Thanks for watching.